My name is Skyna Macaw and welcome to my Lab 2 video on lines of charge. The goal of this lab is to estimate the charge on a tape strip, the same as Lab 1, but using improved methods. In Lab 1, we took the tape to be a point charge when doing our calculations, but for Lab 2, we used the concept of distributed charges to better estimate the charge. The same steps were followed as in Lab 1 to create a charge tape. First, stick one piece of tape to the table and then lie another piece on top. Rip the first piece off rapidly and now you have a charged tape. Test it by bringing it close to other charged objects to see how it reacts. If it moves towards your hand, that means it's successfully positively charged. Make another one of these tapes and set the two up as in the diagram. Bring the first piece of tape underneath the second until it starts to float. Measure the distance between the two tapes at this point. For me, it was 0.0127 meters. The basis of this lab is the same as Lab 1, using Coulomb's law and Newton's laws, but also includes the use of superposition and distributed charges. This means that the tape is split up into n equal portions, each with the nth of the total of the charge on it. Q equals Q tot over n, so each portion is equal. The higher n gets, the more accurate the estimation of total charge is. When doing this experiment, there are a few things that need to be taken into consideration. First, in order to float the top tape, the net electric force must balance out gravity, same as in Lab 1. There are also a few assumptions that we must make. We will ignore air resistance, assume that each tape has the same charge, and that that charge is evenly distributed along the length of the tape. We're going to use the same data from Lab 1, including the charge Q, which we found to be 5.38 times 10 to the negative ninth using Coulomb's law. Now for the coding portion. We are given a starter code and have to go in and manipulate it to fit our experiment. On screen are some of the adjustments made to the code, including creating and placing arrows in the right place, defining values, and calculating the electric field and force. I have linked my code in the description. The value produced for the electric force came out to be 1.85 times 10 to the negative 4. What if the tapes were modeled as a single point charge? Compare the line model versus point model. Since Lab 1 used the point charge model, we already know the value for that, and we just calculated the line charge one. Point charge was 1.6 times 10 to the negative 1, and the line 1 was 1.85 times 10 to the negative 4. Why do the estimates differ? This is because the two models are very different in terms of accuracy. The more n's used means the more accurate the estimation is, and the point charge model, n was 1, and in line it was 25, which is much greater. So that means that the second model is more accurate. That's all. Thanks for watching.